Many devs, DevOps, and platform engineers struggle with implementing application networks. Configuring connections among pods inside a Kubernetes cluster is straightforward enough, but connections that share data between clusters and across cloud environments are difficult to implement. Did you know there is now a simple solution to network applications across environments? And it delivers important security benefits too. A first-of-its-kind Workload Security Proxy, or WoSP for short, was developed by Hopr specifically to ease the friction and improve the security of networking containerized workloads across all cloud environments. In this short video, I'll explain the important advantages and benefits of WoSPs that are possible because of unique cloud-native innovations. A WoSP is a small, lightweight container that is deployed as a sidecar to a host workload, such as an application running in a Kubernetes environment, but it could also be used with a containerized IoT device. WoSPs deliver the advantages and benefits that you see listed here. I'll walk through each of them briefly in the rest of the presentation. But at a high level, WoSPs do three things. They simplify application networking, they reduce cyber risk, and they increase cyber resilience. And they are future-ready and future-proof for the cloud. Let's take a closer look at the advantages and benefits. The Hopr WoSP uniquely decentralizes identity and secrets management, reducing the reliance on conventional cloud and third-party services that add management overhead, cost, and complexity. You can think of decentralization as liberating workloads from the centralized cloud services so that secure data sharing is streamlined. This is because conventional central identity solutions have boundaries that constrain transport layer encryption and force its termination or complicate the transfer of data across the boundaries. WoSPs eliminate the complications from conventional identity trust boundaries and simplify connections between applications in any cloud anywhere. Data can be easily shared without regard for the existing transport layer encryption boundaries. WoSPs have the unique capability to recognize untrusted connection attempts. This means that they can protect public-facing API endpoints and prevent data leaks from misuse of stolen keys, disrupting the attack before it can occur. And this occurs without needing intelligence or knowledge of threat behavior. The next advantage is possible because of the WoSP's identity credential, the MAID. Trust verification of every workload at the start of a communication session is a unique advantage of the WoSP. And as workload communication sessions occur, a chain of trust in the workload grows stronger. This is not possible with conventional identity certificates. The verification of workload trust at each communication session at the speed and scale of the cloud is important because of the US Zero Trust mandate to continually verify trust at every transaction. Another WoSP advantage is the use of symmetric encryption only, which means that the encryption is not vulnerable to quantum computing attacks, a future problem with ever-increasing risk. The end-to-end encryption without exchanging the symmetric key ensures that data is confidential and tamper-proof wherever it travels between two WoSPs. Up to this point, I have discussed advantages and benefits that exist when two WoSPs are configured to use the same chip's algorithm, which happens when DevOps configure them at deployment and run their CI/CD pipelines within a single organization. But application networks also involve workloads operating in different organizations. For example, banking application workloads and API endpoints share data with third-party credit card payment processors. Sharing the same chip's algorithm among these organizations would be a security risk. An attack on one organization could impact all of the other organizations in the ecosystem. Each organization should use its own chip's algorithm and not share it with others. A different WoSP configuration is used to solve this problem, and it performs a Kerberos-style identity trust verification of both authorized workloads when they are configured to use different chips' algorithms. If the identities of the two WoSPs are trusted, they receive a chip's algorithm for their direct secure communication session. Hopr's Kerberos for the Cloud, WoSP, or K4C, enables third-party application networking with the same verified trust, quantum-proof, cyber-resilient capabilities that workloads within an organization get. Also, an important cyber risk and resilience benefit comes with the use of WoSPs. We know that access credentials are a high-value target for cyber threat actors, and that sophisticated, advanced persistent threats are able to penetrate network defenses and operate undetected. These reasons are why WASPs hop the made credential and ephemeral encryption key at a high frequency. The hopping creates an automated moving target defense that prevents attackers from finding and abusing workload access credentials. And the two credentials hop at different frequencies with cycles that interlock, making it nearly impossible for an attacker to obtain the right combination before the next hop. This cloud-native form of AMTD is an effective cyber defense because it disrupts attacks before they can occur. But these advantages and benefits are not very helpful unless the WASPs simplify configuration, deployment, and maintenance. There is good news here too. WASPs are much simpler to configure and deploy than conventional app networking solutions that involve trial and error implementations and are difficult to maintain. A simple DevOps-friendly process eliminates the need for complicated integration and code changes necessary to accommodate external centralized cloud managers. Hopr WASPs are an ideal fit for cloud application networks that operate in high-risk industries such as financial services, healthcare IT, critical infrastructure, and national defense. The cloud-native containers enable on-demand, quantum-proof, ultra-secure application networking with verified trust across all cloud environments. You can learn more at hopr.co